Hi, welcome to InstaCluster. Today I'm going to show you what it takes to deploy a Kafka cluster on our managed services platform. Now, normally when you deploy a Kafka cluster, you have to provision a server, you have to set up Zookeeper, you have to set up Kafka, you have to configure the two services to talk to each other, and in general you require three machines. You have to set up not one, not two, but three servers. And if you want to build these things to be reliable, they should each be in three separate availability zones. And if you're a large enterprise that is concerned about security or compliance, then you're probably going to want to enable things like SSL, authentication, secure encryption between the client and the application clusters. So setting all of these things up in your own infrastructure on premise or in the cloud could probably take you weeks, maybe a month of time. Not a simple process. So let me show you what it takes to set up a cluster. So first you create an account, but I already have an account, so I will simply log in to my account. So now I'm in my account. Let me show you what it takes to create a cluster. So in our managed services platform, you can deploy Cassandra, Kafka, Kafka connectors, or even Elasticsearch. But today we'll just cover Kafka. I'm interested in the Kafka REST proxy and the schema registry, both of which will be deployed in a clustered environment. So every Kafka REST proxy will exist on each server in the node, and the same thing with the schema registry. Now, in our platform, you notice we have a private network cluster. If you want to make it very private, you want to VPN into it, or if you want to deploy it in your environment and you don't want it to be a publicly exposed cluster. So that's where you click on this option. Next, we also offer a PCI compliance mode. So basically, to make a cloud offering PCI compliant, it has to be very secure and it has to run in AWS. Now, you can deploy a Kafka cluster using our managed platform virtually anywhere. Amazon Web Services, Microsoft Azure, Google Cloud Compute, even on-premise installations. We can deploy this in any AWS region, and we have many different offerings as well. Today, we will start with just the developer node. So we'll deploy three machines for about that much per month. We have the option to encrypt the disk at rest. We'll have a replication factor of 3. So your data is copied not one, not two, but 3 times to each machine. And the best part is each machine will be in its own availability zone. So if you're familiar at all with Amazon Web Services and availability zones, in every data center region, they have 3 facilities, each of their own power systems and backup. And when you're provisioning an enterprise data services application, you want to make sure that each server is running in its own availability zone to ensure maximum survivability in a business continuity disaster. Now, when you deploy Kafka, you have many options. The first thing I would select is to add this firewall rule. By default, Kafka is a 100% lockdown secure solution. So if I want to connect to the Instacluster Managed Services Kafka solution, I have to add a firewall exception to grant access to myself as the administrator. Next, you also have client and broker encryption, which is not supported on developer-sized nodes, but the option is available. And then you have the option to enable topic auto delete or creation. And I can select the default partitions per topic, which in this case is set to 3 partitions per topic. When running the Kafka REST proxy, we will also deploy our own server. Finally, we have SLA tiers. If I chose a larger cluster, I would have the ability to increase the SLA. We do charge an add-on enterprise service fee for the REST proxy and schema registry, but it's only 20%. Now let's create a cluster. So if we go over here, we can see the status of provision and cluster is already at 56%. Fantastic. Let's take a look at this running cluster instead. So in our managed services platform, we have many different ways in which you can look at the cluster. So as you can see, we have 3 public IP addresses. Each of them are running Zookeeper, Kafka, the REST proxy, and the schema registry. 4 applications on each server. But you know what? That's just fine. Here you can modify the settings of your cluster. You can enable two-factor authentication. Here are the firewall rules. So as you can see, I've added my own public IP address. My public IP address is right here. You can also do the same thing with schema registry and REST proxy. Our solution is a PCI compliant, highly secure solution. It's also SOC 2 compliant. Also, you have the ability to add multiple data centers and set up VPC peering. So in here, you can actually enter in an AWS account ID, a VPC ID, a VPC network, and a region, and submit the VPC peering request, which will enable the tunneling between your data center and our InstaCluster data center. Or this might be necessary if you want us to deploy our infrastructure in your environment. The connection info is pretty easy. You have these public IP addresses, this one, and the private IP addresses. Generally, you have the option to enable client and broker encryption, which is currently disabled, and password authentication, which is enabled. The username and password is here. Please don't tell anybody. And you have the facility to manage users and topics, which we'll cover later. But first, let's simply discuss how you can start using your Kafka cluster, which is pretty exciting. So the first thing you got to do is you got to download Kafka, which is pretty simple. And then you need a Kafka configuration file, which is called Kafka properties. You're going to want to put this in the same folder as all the commands below to make this process as easy as humanly possible. So if I were to simply copy and paste this into my Kafka.properties file, you'll see that all my configurations are readily available. Fantastic. Now let's create our first Kafka topic. I think that's a fantastic idea. So, why don't we walk through this command? We're connecting to the Bootstrap server 54.203.221.103.92. Does that number look familiar? Why, yes, it is. You can see it right here. We're reading from the properties file, which we edited up here, and we are going to create a topic called test, which has a replication factor of 3 and just 3 partitions. And what do you know? In about 30 seconds, we have a running Kafka cluster with SSL tunneling, with SASL-based authentication, and it's a highly secure solution. So I didn't have to spend weeks setting this up. I have it up and running in mere seconds. But since I'm an end user, I would like to start running commands with this. Well, why don't we start a Kafka producer? So here's our producer. As you can see, it's running. Here's our consumer. Why don't we see if it's working and just send a hello world. There you go, it works. Why don't we just start sending some numbers? Fantastic. We have just provisioned an enterprise-grade, fully horizontally distributable Kafka solution. We also have REST proxy, readily available, and the Kafka schema registry. In fact, if you're feeling bold, you could actually copy and paste this code and start using the Java examples. All this example is readily available in all of the select programming languages. So you have Java, Python, and C Sharp. Fantastic. But why don't we dive into more of how you would manage an Instacluster service? So we have topics. We basically have our own command utility called IC Kafka Topics. We forked our own topic utility program simply because we do not allow access to Zookeeper. We're a highly secure solution, and unless you specifically want access to Zookeeper, we generally hide access to it. Now, let's talk about users. You can manage your users here. In fact, if you're feeling extra bold, we have a very fantastic feature called access control lists. So if you need to grant or deny privileges to specific Kafka topics to specific users of your application, we have that enterprise grade feature readily available for you. Additionally, the wonderful thing about us is at any given point in time, you can easily increase the number of nodes, and this will happen automatically. We'll redistribute the partitions, we'll redistribute the data nodes, we'll handle everything for you completely automatically. You will not have to spend a month planning on increasing the size of your cluster. Well, this is all great and all, but I'm a concerned DevOps engineer, and so might you be. I would like to know how my cluster is running. Well, that's a great question, because right here on our monitoring dashboard, you're able to readily see CPU usage, disk usage, broker bytes in, and broker bytes out. Absolutely incredible. Well, that's great and everything, but what if I'm a engineer and I want to know everything that's going on? Well, that's a great question. What if I want to look at Kafka level details? Okay, let's take a look at that then. We can see synthetic transactions, our overall producer latency, how many messages are we processing, how many errors are we experiencing, what's our average consumer latency, and on again. Broker topic metrics. We can see delayed operations, such as your fetch and produce purgatory size. Leader election, which is a pretty important thing to watch. Obviously, you never want any unclean leader elections. That means something's not good. And you only want one leader. So there's two leaders here. That's looking pretty good. Unclean leader election. We always want this to be 0. If that is not 0, that is a problem. Message conversations. So you have the produce message conversations per second. Another fantastic metric. Okay, great. So seeing our network request and idler handler, what about offline partitions? Good, 0. You never want partitions offline. How many partitions are there running in the cluster? Well, there's 57. Active controllers. You only want one controller in a cluster. Okay, so I've covered most of the broker topics. Let's talk about things that matter to you, the end user. I want to see consumer lag. How many messages am I behind? Well, look at that. Consumer 2 is 24 messages behind, and you can see how many partition counts there are per client and how many consumer counts there are per client. So you're able to readily see consumer lag. Why don't we look at Kafka topic level metrics? Great. We're going to look at the topic Instacluster SLA. Messages in, bytes out, and the fetch rate. Fantastic. And there we go. This concludes the overview of our Kafka Managed Services offering. If you have any more questions, please contact our team here at Instacluster.